Data is getting generated at a massive rate every second nowadays. Companies are trying to explore every opportunity to make sense of this data. This is where data analytics has become crucial to drive profits and overall business growth. Although there are many languages to perform this data analysis, Python has emerged as a popular language for data analysts thanks to its built in analytical tools and libraries. On that note, hey everyone, welcome to Simplicode's YouTube channel. I hope you guys are doing good and staying safe. In this tutorial on football data analysis using Python, we'll perform a thorough analysis on the English Premier League dataset and derive some inferences using data visualization tools like Matplotlib and NumPy. The English Premier League, or just Premier League, is the top tier football league in England with 20 teams participating in it every year, and data analytics in football has been a major contributor to these club franchises for squad building and developing strategies against opponents in the sport of football. So let us first understand the dataset that we are using today. Over to our training expert.
Right, so here is the EPL 2020-2021 season dataset that we'll be using for our demo. So the first column, you can see the names of the different players that play in the English Premier League. So we have around 532 players participating in the EPL last season. Then the second column is about the club they belong to. You can see we have the different clubs. First is Chelsea, we have Manchester City, Man United, Liverpool, Leicester, West Ham United, Tottenham, Arsenal. And if I scroll down, you can see the other clubs such as the clubs like Aston Villa, we have Everton, Wolverhampton Wanderers, we have Crystal Palace and others. Now coming to the third column, which is about the nationality of the players, that is the players belonging to the different nations. We have England, I think this is Senegal, Germany, we have France, Spain, Italy, Brazil, Croatia and others. Now the fourth column is about position, that is the position at which these players play at. Now you can see some of the players play at different positions. They can play for two different positions, like for example Mason Mount from Chelsea plays as a midfielder as well as a forward. Now Edouard Mendy is a goalkeeper, DF is for defender, so on and so forth. Now next we have the age of the players. We have the total number of matches played by each player in the last season of EPL. Then we have the total number of starts the player got, that is whether the player was part of the playing 11 or not. Then we have the total number of minutes the player had played in the last season of EPL. This is the total number of minutes the player had played. Next we have the total number of goals scored by each player. We have the total number of assists given by each player. Then we have passes attempted, the percentage of passes completed. Up next we have total number of goals scored from penalties, and then we have total number of penalties that were taken. Now we have two different columns, XG and XA. So XG is the expected number of goals from the player in a match, and XA is the expected number of assists from the player in a match. And finally we have the last two columns, total number of yellow cards received by the player in the last season of EPL, and then we have the total number of red cards received by the player in the last season of EPL, that is 2020-2021. So we are going to use this data set and we'll be analyzing and answering specific questions such as the total number of goals scored, the total goals scored on penalties, and the total goals that were missed while taking penalties. Then we have players from different nations playing in EPL. Then we'll also look at which clubs have the maximum number of players in the squad. We'll be also analyzing the players based on their age group. Then we'll see the total goals scored by the top 10 players in the last season of EPL, and we'll be visualizing these results with the help of different charts like the bar chart, the pie chart, and we'll also create plots using libraries like seaborn and Matplotlib. So let's head over to our Jupyter notebook. Let me show you the Jupyter notebook that we'll be using. Cool. So this is my Jupyter notebook that I'll be using for this live session today. You can see I have renamed the notebook as EPL 2020-2021 Data Analysis Demo. And I have some of the cells filled already. This is to make sure we save some time. Cool. So first and foremost, let's go ahead and import the necessary libraries that we'll be requiring for our demo. So first, I'll import the data manipulation library, which is pandas as PD, and then we'll import NumPy as NP. Then I'll have Matplotlib dot pyplot as PLT. After that, we'll be importing the second data visualization library, which is seaborn as SNS. Finally, I'll say percentage matplotlib inline. So we'll get our results just right below the code once we run graphs. So let me hit Shift Enter to run this first cell. All right, you can see we have successfully imported the different libraries. Now the next step is to load our EPL dataset. So I'll create a variable called EPL underscore DF, which essentially stands for data frame. I'll say PD dot, since it's a CSV file that we just saw, I'll say read underscore CSV. Now within the quotations, we are going to pass in the location of the file, followed by the file name and the extension of the file. Okay, so I have copied the file location. Let me just paste it here within the quotes. Now we are going to give one more backslash so that it reads the location correctly. I guess you don't have to do this if you are on a Linux or Mac system. Now after this, we are going to give two more backslash, and we are going to give the file name, which is EPL underscore 20 underscore 21 dot CSV. Cool. Now the next line, I'm going to print the head of the data frame, that is the first 5 rows of the data frame, that is EPL underscore DF. So I'll say EPL underscore DF dot head. Let's run it. Now you can see the output. We have the first 5 rows printed from the dataset, and you can see the different columns that we have. All right. Now in the next step, let's check the info function that will give the total number of columns that are there, as well as display the total non-null values in each of the columns. So I'll say EPL underscore DF dot info. Let's run it. You can see we have the different column names, and on the top you can see there are total 532 entries. We have total 18 columns. You can see total of 18 columns. These are the total columns, their column names, and on the right you can see the total number of non-null objects, which means we do not have any null value in any of the cells or any of the columns. And at the bottom you can see the memory usage and the data types. All right. Now let's go ahead and use the describe function to get some summary statistics about our dataset. So I'll say EPL underscore DF dot describe. Let's run it. And now you can see we have the count, mean, standard deviation, the minimum value, the maximum value, the 25th percentile, the 50th percentile, and the 75th percentile. Now this describe function only works on numeric columns. Cool. Now let me show you a way in which you can check the total number of null values that are there in each of the columns. For that, we are going to use the isNA function, and over that I'm going to use the sum function to get the total number of null values. Here I'll say EPL underscore DF dot I'll say isNA dot sum. Now let me run it. Here you can see we do not have any null values for any of the columns. Cool. Now let me show you the process in which you can create two more columns, such as the minutes per match, and we'll create another column that is the goals per match. So for that, I'm going to first call my data frame, which is EPL_df, and within square brackets I'm going to give my new column name, that is minutes per match. This should be a valid Python name. I'll say equal to, now the minutes per match should be equal to the total number of minutes divided by the matches, that is the number of matches played. So I'll say EPL_df. I'll divide minutes by, let me give a bracket here. I'll say EPL_df, and then I'll divide it by the matches column, and we are going to set the type as integer. Alright, then the second column I'll create is goals per match. So I'll say EPL_df, and my new column name is goals per match equal to, let's start with a bracket. We'll say EPL_df. We consider the goals column, and then we'll divide it by EPL_df, give a square bracket and say matches, and we are going to convert the type as float. Cool. Let's run it. Now if I say print EPL_df, you can see, or let's say EPL_df dot head to print the first 5 rows. Here you can see we have created two more columns. Let me just remove this print statement and we'll run it again. Now you can see we have created two more columns, that is the minutes per match for each of the different players, and then we have the goals per match for each of the different players. Alright, now in the next cell we are going to calculate the overall total goals that were scored in the 2021 or 2020-2021 EPL season. So let's see total goals. I'll create a variable called total_goals equal to, I'll say EPL_df. We're going to take the goals column, and then I'm going to use the sum function. Now let's print the total goals. If you hit tab, it will autocomplete. Let me run it. Okay, to remove goals. Now you can see there were total 986 goals that were scored in the last season of English Premier League. Now let's find out of this 986 goals, how many goals were scored in penalties. So for that, we are going to use the penalty_goals column. I'll create a variable called total_penalty equal to, we'll say EPL_df, and then we are going to consider the penalty_goals column. Then I'll say dot sum to find the total number of goals that were scored in penalties. If you hit tab, it will give you a prompt. Let me select the second one. Okay. Run it. There you go. Here you can see out of 986 total goals that were scored in the EPL last season, 102 goals were scored out of penalties. Now in the next analysis, we are going to see the total number of penalty attempts that were taken and how many converted. So for that, let's create another variable called total underscore penalty attempts equal to, now this should be the penalty attempted column. So I'll say EPL underscore df. We are going to consider the penalty underscore attempted column. Say dot sum to find the total number of penalties that were taken, and we're going to use the print statement. Let me hit tab and I'll select penalty attempts. Let's run it. So overall 125 penalties were taken, out of which 102 got converted, the rest all were missed. We are going to create our first plot in our live analysis about the EPL 2020-2021 season. So we are going to create a pie chart for penalties scored and missed. Okay, so first of all, we are going to set our plot figure to a certain size. Let's say I'll say figure size equal to, and this will be a tuple. Let's say I'll say 13,6. Now I'll say penalty not scored equal to a data frame that is EPL underscore df. I'm going to pass in my penalty underscore attempted column and sum it, and I'm going to subtract the total penalty goals. So that is total underscore penalty goals. Say data equal to, this will be a list. So I'll say penalty not scored. Let me just copy and paste it, comma. We're going to pass in total penalty goals. Also give labels to our pie chart. So the labels will be penalties missed, penalties scored. Make sure you put it within quotations. We are going to give color to the pie chart. So for that, I'm going to use my seaborn library. I'll say sns dot color underscore palette. Say I'll set my color palette to set 2. You can check for different color palettes. Just Google seaborn color palette and click on the first link. If you scroll here, you can see the different color palettes. You can see tab 10. Then you also have HLS, HUSL, which is for hustle. You have set 2, paired. But scroll down, you have rocket underscore r, rocket. You also have cube helix, then magma and others. All right, let me come back. So I'm using the set 2 palette, and we'll say plt dot create the pie chart. We are going to use the pie function, and we'll pass in our data followed by the labels parameter, which is equal to the labels that we have declared above, which is this one. Okay, now I'll say the colors parameter should be equal to the color palette that we have defined in the above line. Next, we are going to use auto PCT. So this auto PCT enables you to display the percentage value using Python string formatting. So you can use the auto PCT to display your percentage values. Let me give a certain formatting, percent dot OF, which is for string. I'll give 2 percentage values. Finally, I'm going to say plt dot show to display my chart. Cool. Now let's run this. Okay, there is an error here which is plot dot figure. This should be plot dot figure and not underscore. There you go. You can see we have our first visualization for the 2021 EPL data analysis demo. You can see 82% of penalties were scored while 18% were missed. Now next, we're going to find the total number of unique positions for which each of the players play for. That is, this will also tell us the total number of positions that are there in football. So I'll say EPL underscore DF. Let's consider the position column, and I'm going to use the unique function to find the total number of unique positions that are there, such as the center forward, midfielder, defenders, goalkeepers, etc. If I run it, you see here we have goalkeeper, midfielder and forward, forward, defender, midfielder, defender and midfielder, etc. Now you can see some of the positions are a combination of two positions, which means a few of the players play for two different positions on the pitch. All right. Moving forward, we are going to see the total number of forward players that played in the last season of EPL. So for that, I'm going to say EPL underscore DF. Again, within square brackets, I'll say it's EPL underscore DF, and we are going to consider the position column, basically subsetting the data frame to derive valuable information. Now this should be equal to my value, which is FW, that is forward. Let's run it. There you go. So here, if I scroll down, you can see the different players that played for, there are total 81 rows, which means 81 players in the EPL played as forwards. You can see Timo Werner from Chelsea, Tammy Abraham, who currently plays for Roma in Italy. We have Oliver Giroud, then we have Raheem Sterling. Also have Billy Sharp from Sheffield United and Daniel also. Next question that we are going to answer is, we'll see the players from different nations. So we'll see in EPL what are the nations or the total number of nations from which players come from. So I'm going to use this function called numpy.size, and within brackets I'll say EPL underscore DF. We're going to consider the nationality column to find the count. So I'll say nationality, and we are going to use the unique function to get the total number of unique nations from which the players play in the EPL. If I run it, you can see here there are total 59 nations from which the different players play from. Now let's see the most players come from which nations. For that, I'm going to create a variable called nationality equal to, I'm going to use my data frame EPL underscore DF followed by the group by function. First, we are going to group by nationality column, and then I'll say dot size, and we are going to sort values in ascending order. So for that, I'm going to use the ascending parameter, and I'll set it to false, which means we are going to print in descending order and not ascending. Next, I'll say nationality dot head, since I want to know the top 10 nations from which most of the players come from. We're also going to plot it. This should be a bar chart, so I'll say kind equal to bar. Let's give a figure size equal to, let's say, 12,6, and now I'm going to say color equal to, we are again going to use the seaborn color palette, so I'll say sns dot color underscore palette. This time we are going to choose, let's say, magma. All right, I think everything is fine. Let's just run it. Great. Now if I scroll down, you can see the different nationalities, the top 10 nations from which the most players come from. Of course, since EPL is in England, or is hosted in England, so most of the players are from England. Then we have the most number of players playing from France, Brazil, Spain. This is Ireland, I guess. Then we have Portugal, Scotland, Netherlands, Wales, and Belgium. Cool. Now, moving forward, let's come to the next cell. We are going to see the clubs with maximum players in their squad. This will tell us the clubs, let's say the top 5 clubs which have the maximum players in their squad, or had the maximum number of players in the 2020-2021 season. We're going to consider the club column, and we're going to count the total number of players. So I'll say value underscore counts. Let's use the n largest function to get the top 5 clubs, and we are going to plot it again. This will be a bar chart again, so I'll say kind equal to bar, comma, and we'll say color equal to sns dot color underscore palette. Let's choose a new palette, namely Viridis. So I'll write it correctly, Viridis. Fine. Let's run it, and here you can see we have West Bromwich Albion, which had nearly 30 players in the squad. Then Manchester United, I think they had 29 players in their squad last season. Then Arsenal with the third highest number of players, followed by Southampton and Everton. So last three had the same number of players, close to 29 or 28. All right. Now, similarly, if you want to check the clubs with the least players in their squad, we just need to use the n smallest function. Here I can copy this cell of code. We'll just edit it. Instead of n largest, I'll say n smallest. Cool. Rest everything remains the same. Run it. You can see here Leeds United had the least number of players in their squad, followed by Manchester City, Crystal Palace, Tottenham Hotspur, and West Ham United. Cool. Now in the next analysis, we are going to see the players based on age groups. So we are going to define 4 age groups. Let's say players less than 20 years of age, then players between 20 to 25 years of age, then we have players from 25 and 30, that is 25, between 25 and 30, and finally we have the different players who are above 30 years of age. For that, I'll create my first variable, which is under 20. This should be equal to EPL underscore df. I'll say EPL underscore df. We'll consider the age column. Again, we are subsetting the data frame, so I'll say less than equal to 20. Then we'll have age between 20 underscore 25 equal to EPL underscore df subset as EPL underscore df. Consider the age column. It should be greater than 20. I'll say ampersand and EPL underscore df. Use the age column should be less than equal to 25. Just copy this. Next, we are going to see for age between 25 and 30. So I'll edit my variable name 25 underscore 30. Here, this should be greater than 25 and less than equal to 30. Cool. Finally, we'll have players above 30 equal to, I'll say EPL underscore df within square brackets. I'll say EPL underscore df. We'll consider the age column should be greater than 30. Cool. Let me run it. And now in the next cell, which is already filled, this is to create the pie chart for the above age groups that we created to see the players based on different age groups. So this is very similar to creating a pie chart again. So first of all, I'm creating a NumPy array for all these 4 variables, and we are going to consider only the name. Then I'm setting my labels as less than equal to 20, greater than equal to 20, and less than equal to 25, greater than equal to 25 and less than equal to 30, and then above 30. I have the title as total players with age groups. Let's see. The font size as 20. Cool. Let's run it. And you can see we have our pie chart. So from the pie chart, you can see in the last season of English Premier League, at least 37% of the players were aged between 25 and 30. And then we have 35% of players who were between 20 and 25. 13.3% of players were above 30 years of age, and we had 14.7% players less than equal to 20 years of age. Now, if you were to check the total under 20 players in each club, so for that, I'll say players under 20 equal to, again we are going to subset our original data frame, EPL underscore df. I'll say EPL underscore df. Age should be less than 20. Next, we'll say players underscore under 20 consider the club column, then values underscore count. Let's plot. I'll say kind equal to bar. Again, we are going to choose the color equal to SNS dot color palette. Let's say we'll go with cube helix. Cool. Okay, let's debug the error. There are some errors. It says series object no attribute values underscore count. This should be value underscore counts. Now let me run it. Cool. You can see there are 7 players, or there were total 7 players in the Manchester United club who were less than 20 years of age, followed by 5 players in Wolverhampton Wanderers, then Sheffield United, and the rest of the other clubs you can see. Now let's find out all the players who were aged less than 20 in Manchester United. Well, let me just scroll down. Cool. So here I'll see players under 20. Again, we're going to say players under 20 to subset based on club equal to I'll give the value as Manchester United. Run it, and you can see the 7 players that we saw above. Here you could see we had 7 players in Manchester United that were aged below 20, and the names are Mason Greenwood, we have Brandon Williams, Ahmad Diallo, Anthony Alanga. We also have William Thomas Fish. Cool. And you can see that ages here 18, 19, all of them are less than 20 years of age. And similarly, you can also check for other club. Let's say you want to see the under 20 players in Chelsea. We just need to replace or subset our club for Chelsea. There are only 2 players who were aged less than 20, Callum Hudson-Odoi and Billy Gilmore. Cool. We're going to create a plot to see the average age of players in each club. So for that, I'll say plt.figure take the figure size as, let's say, 12,6. Then we're going to use the seaborn library and the box plot this time. So the box plot is a good way of finding the variability in your data. It will give us the mean, the median, the 25th percentile, the 50th percentile, the 75th percentile, the maximum value and the minimum value. And the box plot will also show if there are any outliers in the data. So my X will be club, my Y value would be age, and my data will be my original data frame, that is EPL underscore df. I'll say plt.x ticks, and we are going to say rotation equal to 90 degrees. Let's run it. If I scroll down, here you can see we have the box plot. So for Chelsea, you can see the minimum age value, the maximum age value, and then you also have an outlier here. I'm assuming this is someone who's aged above 36 or 37. And then here you can see the median, and similarly you can see for the rest of the other clubs. Now if you notice, I can see here that Crystal Palace has the highest average age. If you see this line, now this line is the maximum for Crystal Palace. Now to verify the clubs with the average age of players, I'll say, let's say num underscore player equal to EPL. Let me just scroll down. Score df dot, we'll use the group by function on club, and I'll say size. To that I'll say data equal to EPL underscore df dot, and I'll group it by club. Say age dot sum, and we are going to divide it by the variable that we created above, that is num underscore player. Finally, I'll say data dot sort underscore values ascending equal to false. Let's run it. Okay, it has thrown an error. It says sort underscore values got an unexpected keyword argument ascending. Okay, there's a spelling mistake. This should be ascending. There you go. So as we saw above in the box plot, now here you can see Crystal Palace has the highest average age in that team, which is 28.3 years. Then we have West Ham United, followed by Burnley. Now if I scroll down, Manchester United had the least average age of players. That means they had a very young team that played in the 2020-2021 season. After that, there were West Ham, Aston Villa and other clubs. Great. Now in this cell, we are going to find the total assists from each club. For that, I'm going to group by club, and we are going to find the sum over the assists column. After that, I'm going to create a bar plot. In the x-axis, we'll have the club names. On the y-axis, we have the total number of assists. Then I'm setting the palette, the color palette, to set to. We have an X label, we have a Y label, we have the font size for the labels. I'm going to rotate the x-axis labels by 75 degrees. We have the figure size set, and the title as plot of clubs versus the total. This should be assists. Let me run it, and you can see here we have the total number of assists for each of the clubs. As you can see, Manchester City had the highest number of assists, which were above 50 or around 55. Cool. Let's see the players who gave the most assists in the last season of EPL. So for that, I'll create a variable called top 10 assists equal to, I'll use my data frame name EPL underscore df, followed by name, then club, then this column, and I also want the matches column. And I'm going to use the n largest function to find the top 10 players. So I'll say n equal to 10 columns equal to assists. Let's print the top 10 assists. Let's run it. Okay, again there is an error. Let's debug it. It says invalid syntax. Let me check. Club, assists, matches, then we have n largest equal to n equal to 10, columns equal to assists, and this should be a comma. Cool. And here you can see we have Harry Kane from the last season of EPL who gave the maximum assists, that is 14, followed by Kevin De Bruyne from Manchester City, who gave 12 assists, followed by Bruno Fernandes from Manchester United. He's a Portugal player and he gave 12 assists. Song Hyung-min from Tottenham Hotspur, he plays for South Korea and he also gave 10 assists. Jack Grealish gave 10 assists. Then we have Marcus Rashford, Jimmy Vardy, Timo Werner, and other players. All right. Now in the current cell, which is already filled, we are going to find the total goals from each club. Earlier we saw the total assists from each club. Now this will show us the total goals from each club. If I run it, now you can check. We have Manchester City, which scored above 80 goals last season, followed by United, that is close to 70 or exactly 70 goals they had scored, followed by Tottenham Hotspur. We have Liverpool, Leicester, by Sheffield United and Fulham, as well as Burnley had close to 30 or less than 30 goals. In fact, Sheffield United scored less than 20 goals. Cool. Next, we are going to check the most goals by players. So I'll say top underscore 10 underscore goals equal to, I'll say EPL underscore DF. Again, we are going to take the name column followed by the club. By this time we are going to consider the goals column. Also take the matches column. Say n largest, make sure there are no spelling mistakes. Say n equal to 10 columns equal to goals, and let's print players with the most number of goals. You can see here Harry Kane played 35 matches in the last season of EPL and scored the maximum number of goals, so he should have won the Golden Boot as well. So he had scored 23 goals, and if you see the above table that we created, he also gave the most number of assists. So he's a brilliant player from England, plays as a striker and currently the captain of England as well. After that, we had Mohamed Salah, who scored 22 goals, followed by Bruno Fernandes, who scored 18 goals from 37 matches. Then we have Song Hyung-min, we have Patrick Bamford from Leeds United, who scored 17 goals, etc. Cool. Now in the next cell, we are going to find out the top 10 goals per match. That is the goals scored in each of the matches. We are going to find the percentage. I'll create a variable called top 10 goals per match equal to EPL underscore DF. Calculate the name, and also take the goals per match column. If you remember, we had created this goals per match column above. Let me just show you in case you forgot. Here you can see we had created this extra column called goals per match. This is the last column that we have in our data frame. This is basically the total number of goals divided by the total number of matches the player had played. If I scroll down, we are going to take the name column, the goals per match. Next, we'll consider the matches column, and then we'll also take the goals column. Dot, I'll use the n largest function and say n equal to 10, comma, columns equal to per match. Finally, let's print the top 10 goals per match. Here you can see we have Akin scored 0.6 goals in a match. Then we have Mohamed Salah with 0.59, Joe Willock with 0.5, Jesse Lingard scored 9 goals in 16 matches, so his goals per match stands at 0.5. Basically, it is the total number of goals divided by the total number of matches. Cool. In the next cell, we're going to create a pie chart that will show us the goals with SS and without SS. So I'll start with my pie chart as plt dot figure. We'll set the figure size to 14,7. Create a variable called SS equal to, we're going to find the total number of SS. So I'll subset my SS column and I'm going to use the sum function over it. Then I'll see data equal to, we're going to take the total goals minus SS comma, and then we'll have SS. Let's set the labels as well. I'll say labels equal to goals without SS, and next label will be goals with SS. Next we'll say color equal to SNS dot color palette. Say I'll take set 1, and finally we are going to use the plt dot pie function, give my data and labels equal to labels, colors equal to the color that we just set above. We'll again use the auto PCT parameter to give the percentage values. I'll say within quotations percentage dot 0 f percentage percentage. Display, I'll say plt dot show. Everything is fine. Let me just recheck it and we'll run it. It says pie got an unexpected error color. This should be colors equal to color. Is not defined. Again, let's, okay, this should be plt dot show. There you go. So you see we have our pie chart, and in the pie chart you can see at least 69% of the goals were scored with SS, and the rest of the 31% goals in the last season of English Premier League were scored without SS. Coming to the final plot in our live demo session on English Premier League data analysis, we are going to see the top 10 players with the most yellow cards. So basically the players who commit the most number of fouls in a game are given a yellow card or a red card. So for here I'm using the yellow cards column, and I am going to find out the first 10 players with the most number of yellow cards received in the last season of EPL. Let's run it, and if you see, we have John McGinn, who plays for, I guess, Aston Villa, received the most number of yellow cards, that is 12, followed by the captain of Manchester United. This is very surprising. Harry Maguire got 11 yellow cards last season, followed by Conor Gallagher. And we have Douglas Luiz, Kevin Phillips, Mason Holgate as well in this, as well as Ruben Neves. Okay, so that brings us to our live demo session on football data analysis using the English Premier League 2020-2021 dataset. You understood how to load the dataset, and then we explored different functions that are available in NumPy and pandas. After that, you saw how to create pie charts, bar graphs, and then you also created a box plot. We saw the total number of goals scored by each club, the total number of assists, the players with the highest number of goals, the players with the highest number of assists, then the goals that were scored in penalties and without penalties. All right.
And that brings us to the end of today's session, guys. I hope you understood all the concepts and topics covered today in this live session on football data analysis on the EPL dataset 2022 using Python. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the channel for more such amazing content. Until next time, stay safe and keep coding.